All right, so we are going to be looking at the third section of equations. So the dissolution or solubility, this is when soluble crystals like salt, sodium chloride, is dropped into water. Water pulls the individual ions out of the crystals, like oxygen, which is negative, end of water surrounds the sodium, which is the positive end of the ionic structure, and hydrogen, which is the positive end of water, surrounds the chloride ions in the ionic structure. A solution of sodium chloride can more accurately be represented as this, where you have the sodium chloride aqueous solution and the sodium ion and the chlorine ion. So exercise, write the correct representation for the ions present in a solution of silver nitrate. So we've got silver and nitrate. Now looking at your reference table, you know that silver is +1 and nitrate is -1. So how we would put them into solution is as followed, using their appropriate oxidation states. So silver is a +1, where you've got the plus. Aqueous, don't forget that aqueous. Aqueous means it's in solution. And then you have the nitrate, which is the -1, which also is in solution, so you got to put the aqueous down. Okay? All right. So the formation of a precipitate, the solid. When solutions are mixed, some ions remain in solution while others precipitate out, turn into the solid. All right. So Ionic equations give a clearer picture of what happens in the actual solution by showing the individual ions. All right, so looking at this is the molecular equation, what we've been looking at, what we've been balancing. All right, so the next thing we're going to start looking at, let me move this down here a little bit. We are going to start looking at the complete ionic equation. So we've got the molecular equation, and then we're going to pull it out, expand it into its ions in solution. Just like we did previously, we broke up the silver nitrate solution into its individual ions. So that's where you have right here, the silver plus, the nitrate minus. And aqueous, again, make sure showing aqueous. So we're going to break up the silver chloride into its ions in aqueous solution. So sodium +1, aqueous, chloride -1, aqueous. Now on the other side, we see that when silver bonds with chlorine, when you get this double reaction going and you have the switch, silver chloride actually is solid. That's the precipitate. That's what falls out. And you're left with sodium nitrate, which is aqueous. So again, anytime you see aqueous, you break it up into ions. So you got the sodium plus ion and the nitrate minus ion, giving you the whole thing is a complete ionic equation. All right, so you have the molecular, then the complete ionic equation. So in that ion equation, you notice that there are ions that don't participate or change in the reaction called spectator ions. This is kind of like, think of when you're at a sports game or a meet or something. The spectators, the people in the stands, they don't actually participate in the sport that is happening, but they watch. They just watch what's going on. They don't do anything. They don't contribute except for watching. So what we can do is we can remove all those spectators, all the ones that are same on both the reactant and the product side. So we remove those out. We pull those out and get rid of those spectators, the non-participating, and we're left with a net ionic equation. That means what doesn't change on this side and what doesn't change on this side, I pull out and I get chloride minus ion plus silver plus ion gives you silver chloride, solid. So there's my spectators. So the sodium ion is the same on both sides, so I can circle that. Another one that's the same on both sides is this nitrate ion, so I'll circle that. I get rid of those, and I'm left with that silver nitrate. So how about we look at this one in the yellow pages? It is barium chloride and potassium sulfate. All right, so the first thing we're going to have to do is complete and balance the molecular equation. So I'm going to write up the molecular equation. I'm going to do the switch. I like starting with barium because that's the first thing I see. So I'm going to switch it. So instead of barium chloride, I'm going to have barium sulfate. Then I'm going to have, instead of potassium sulfate, I'm going to have potassium chloride. Right, like this. Now I'm going to make sure that I have the appropriate lost it. Subscripts. There you go. Subscripts. So barium 2 chloride, so that's a +2. Sulfate is a -2 because that 2 right there shows that. So they cancel each other out. I don't have to worry about that. Potassium is a +1, chloride is a -1, so I don't have to worry about that. I do, however, have to balance these out. And don't forget the phases. So my phases, sulfate with barium makes a solid. It is insoluble. Potassium chloride, again, is aqueous. So I'm left with figuring out, balancing the equations. What is on one side has to be on the other. You can't mess with that. It's conservation. So I have one barium here, one barium here, one sulfate here, one sulfate there. Awesome. Don't have to do anything. I've got 2 potassiums and 2 chlorides. So all I have to do is add that 2 coefficient, making it balanced. So I've done one. Now I've got to write out the complete ionic equation. Wherever I see an aqueous, I got to break it apart into the ions. So breaking it apart into ions, I've got barium +2 to chlorine minus. So anytime I see that subscript bar, not including the polyatomics, I pull the 2 from the bottom part, the subscript, and I pull it up to make it a coefficient. So same with the potassium. There are 2 potassiums, so 2 potassium minuses, 1 sulfate, or 1 sulfate -2. Same for here. Notice I left that solid alone. Anytime you see a gas, the liquid H2O, or a gas, you leave them all alone. Don't mess with them. Don't pull them apart. Just the aqueous solutions. All right, so the next thing, I'm going to circle the spectator. What is the same on each side? So let's look at this. Barium 2+, nope. Chlorine 2, yes, I've got the same on that. Potassium 2, yes, I've got 2 of them. Sulfate, no. So next, I'm left with writing the net ionic equation. I'm going to pull out everything that is not circled, and I'm left with this. Okay? All right, so that is it. If you have any questions, please don't hesitate to ask. Remember, you've got an ionic equation worksheet. Part 1 is you're breaking up individual aqueous compounds into the ions, which will help you on the following page to write up the ionic equations. Don't forget to do the study guide because we will be having a quiz. All right, I hope you guys have a great day. And again, if you have any questions, please let me know.